Hello guys, so today we are going to do the estimate surface volume of Lake Baringo, a lake in Kenya, and we want to know the volume of water in this lake by estimate, and we are going to use Landsat 8 and we are going to use the DEM. So we will need band 3 and band 5 so that we can calculate the normalized difference water index. This will allow us to distinguish parts that have water and that do not have water. So with that said, we're going to go on to ArcGIS and load our data. So I'm just going to load my shapefile first. So this is my region of interest. I will double click on it. Should be there. Then I'm going to add my DEM. As well as I will need to add my band 3 as well as band 5. So that said, these are my bands. So for now I can just make this hollow and maybe the outline can be red. So that said, this is the area of interest and you can see the lake is at the top of the shapefile. So let's proceed and do the NDWI first. So that said, I'm going to open the actual box and I'm going to go to the spatial analysis tools and under map algebra, I will open the raster calculator. You can also do the search, just type the raster calculator. So that said, from here you could see the formula. It's green minus near infrared, that's 3 minus 5 band. So if I come back here, I will just go to float, math. Double click on float and then ensure you are typing band 3, subtract from band 5. And then I'm going to divide by this. So I'm going to select again float. So that's band 3 plus band 5. So I'm going to save this to my database. I'm going to save it NDWI. Let me call it lake. Save this, run it. Should just take a few seconds and then we will have a normalized difference water index for this area. After there, we are going to do a clip so that we can have only the area of interest that you're interested in, because I know beyond the extent of the shapefile, there exist other water parts. So that said, it has done. So you can see the white parts represent the areas that have water. And that's the lake that we have is of interest. So with that, I can remove the band 3 and the band 5. And then I will visualize this much better. I can right click on the new file that we have just generated. And then with that, I can change probably the color ramp. Let me go for blues, something like this. So you can now see the dark blue shows the water in a much clearer way. So this said, we will open the raster calculator again. This time we will use the new file, but let's first go to float. And then I'm going to click on that. Then I'm going to say greater than or equal to 0.1. So this to distinguish between, to add sort of a distinction of 0 and 1s, where we can say that 1 is water and 0 is not water. So we can say, maybe say NDWI, reclassified. So we will have reclassified these to 2 classes, and then you can just run that. So that is going to take just a few seconds, and then once you have done that, we can proceed to do the next step. So it's just taking just a few seconds, and it's done. So you can now see it's showing. You can just turn off these off. So it's showing us the blue parts to be the areas with the water and the orange parts that don't have any water. I can just make the orange hollow and just apply that. So you can now see, let me turn off the DEM. So you can now see this is the lake that you are interested in. You have successfully extracted the lake and it's on a standalone. So the next thing we need to do, I need to clip this. If I turn it on, I need to clip these to be within the region of interest. So I'm just going to go to close this and I'm going to search. Let me search clip. And under data management, I will select the NDWI reclassified. as my input raster, and the output has to be my shapefile. So that is what I'm interested in, and the output is the shapefile. I will ensure that I use the geometry of the shapefile, and I will save this to my geodatabase as NDWI probably clip. So I'll just click save and run the algorithm. This will now clip and ensure that we only have taking only the area within the context. So with this, I can remove these as well as these. So these, let's make them hollow again. So we have only the lake at the top of the shapefile. So now to proceed, if I right click on this data and open the attribute table, you can see, let me expand this attribute table. You can see we have 3 classes. These 0 represent the non-water and 1 represent the water. So that said, I want to convert these to polygon, to a vector data, and we are going to do raster to polygon data, raster to polygon conversion. I'm going to open the actual box. Let me go back to table of contents, actual box, and I will go to conversion tools from raster to polygon. Double click on that. So the input raster is the NDWI clip. So the value, you can leave it like that. Let's save that to our database as NDWI probably polygons. So that's it, save, and then the rest you can just leave them like that and just click run. So we are converting this raster to a shapefile, and this is what we have done. If I open the attribute table for this, I should see a few tables here. You can see I have a shape, ID, grid code, length, and the area. Now with this, we can use this now to extract only the areas that the lake takes. So what we will do, we will use the grid code and dissolve these fields of ones and zeros. So that zeros can be 1 and 1 can be together as well. So that said, let me expand this. Let me go back to my table of contents. I will go to geoprocessing, and I'm going to go to dissolve. I'm going to input the feature as the NDWI polygons. I'm going to save these, and I'm going to save these NDWI dissolve. Save these, and then the dissolve field is the grid code because it contains those values that you had seen earlier from the NDWI that we did, where we had created zeros and ones to distinguish between water parts and the non-water parts. Then I'm going to run this. So once this runs, we will have, you can see if I open the new attribute table, I only have now 2 columns, just for 1 and 0. So this said, we will have to now delete the zeros and only remain with ones. Because 1 represents the water part, 0 represents the non-water, and in this case, we are only interested in the water part. So back to table of contents, I will start my editing of this very layer. And once I've started that, just continue. I'll go back to the table and click on that 0. I can click on this X or right click and delete selected. So that said, you can now save your edits and stop editing. So we will have a new file. So let me come switch off this, and now this is what we have. We have successfully extracted the Lake Baringo, and now we can proceed and do analysis with this. So once this has been done, I will use now the DEM. This now we need to use the DEM, and I can now turn off the shapefile. I don't need it anymore. So to proceed this, I will first clip the DEM that takes the shape of the lake. So with that, I'm going to still go back to, let me close this, to clip data management. The input raster in this case will be the DEM in this case, and the extent will be the NDW dissolve, the layer that we just dissolved and edited, and I'm going to use the geometry of it. So I'm going to call this, and I'm going to DEM, probably name it clipped, save it, and run it. So once it's done, it's going to extract the DEM that only takes the area around the lake. It has finished. Switch off the DEM, switch as well as this. Let me remove some of these. They are making this a lot. Even the DEM, I don't need anymore. Same as this. So now we have the DEM that takes the area of the lake. Now this is the lake. This is the DEM that surrounds the lake. So with this, I can now do the surface volume and estimate the water volume in this lake. So I'm going to go to my Arc Toolbox, and my Arc Toolbox, I'm going to go to Spatial Analysis Tools. Under here, I'm going to go to Surface. Sorry, instead of going there, I'm just going to go to my search, and I'm going to search surface volume. Hit enter, and the first option in the 3D Analyst tool, click on it, and then once it opens, input the surface. I'm going to input the DEM that we just clipped that surrounds the lake. The output text file. So this is going to output a .txt file, not a shape file or a raster. So I'm just going to name it surface volume. So it's just going to be sort of an attribute table to show the volume of the water body. So the reference plane, we're interested in the depth, so it will be below. And the planar height, you can leave it as default. The Z factor, leave it as default. Just hit enter. So it's going to run. Just take a few seconds, and it has done. So you can see we have generated a new .txt file. So if I open this and expand it, I should see a new field, which is called volume. So I'm able to visualize the volume of these in both square kilometers, in 3D I mean, and in 2 dimension, as well as this is the volume of this lake. So with that, you will have visualized and extracted the volume of this. So this for the current year. So you could do this for the previous 10 years using different Landsat images, and then you can know the way the water has been rising or falling for the lake. So guys, try it and let me know in the comment section. Please subscribe and like the video. Have a great day.